Hello and welcome to the lesson Algebra. With algebra, they are always expressed with variables. A variable is a letter or symbol used to represent a number or group of numbers. Then we also have a term. So a term is a number or the product of a number and variables raised to powers. So when you talk about variables, you are referring to letters such as A, B, C, D, all up to what? Z. Any alphabet you can use to represent a variable. And when you talk about a term, assuming you are being given an algebraic expression such as 7 minus 3 dot x. Remember I said dot means multiplication. So another example, if you have x squared plus y divided by z. So this is the same thing as x squared plus y over z. Another example could also be 6x, let me put a dot here, to the power 4 minus 3 dots x squared plus 5 dot x minus 18. So with these examples, we can express them in terms. So for example, the first one, where we have 7 minus 3x. So it means that the first term is the what? 7. And the second term is a minus 3x. Then with the second example, x squared plus y over z. So it means its first term is x squared and the second term is the y over x. Now with the 6 times x to the power 4 minus 3x to the power 2 plus 5x minus 18. So this one has a lot of terms. So the first term is the 6 times x to the power 4. Then the second term is the minus 3x squared. Then the third term is the 5x. And the fourth term is the minus 18. So with each algebraic expression, they have several terms. So a term can be described as what? A number. A term could also be the product of a number. Here we have 5 times x, where x is a variable which represents a numeric value. So here is what? The product of a number. And also a term can be variables raised to powers. So raise variables raised to powers. There are various types of terms that can be identified in an algebraic expression. Now with evaluating an algebraic expression, there must be a numeric values for every variable which appears in the expression. You need to replace all variables with the numeric values. Then you simplify according to the order of operation. We've already talked about orders of operation. Now let's look at some examples. Okay, so we are to evaluate the expression x to the power 2 minus 2yz, where x is equal to minus 2, y is equal to minus 1, and z is equal to 5. Okay, so wherever we see each variable, we replace it with its related value. So x is what? Minus 2. So we have minus 2 to the power 2 minus 2 times y is minus 1. Then z, this is z. This is what? 5. Okay, so this is the same thing as minus 2 times minus 2 minus 2. Then we have minus 1 times 5. So this is good. Minus 2 times minus 2 gives us positive 4. Minus 2 minus 1 times 5 gives what? Minus 5. So here is 4. Then we have minus 2 times minus 5. So this gives 4 plus minus 2 times minus 5 gives positive 10. So our answer now becomes 14. So we've been able to evaluate this expression. Another example. We have been given x equals to minus 4 and y equals to minus 2. Okay, so we have to find x squared minus y squared. So our x is minus 4 squared minus our y is minus 2 squared. So this is the same thing as minus 4 times minus 4 minus minus 2 times minus 2. So minus 4 times minus 4 gives us positive 16. Minus 2 times minus 2 gives us positive 4. So this becomes 16 minus 4, which gives us what? 12. Okay. If also been given, you should find the absolute value of y minus the absolute of x. So y is minus 2 minus the absolute value of x is minus 4. So 2 minus 4 gives us what? Minus 2. The last example. Okay, so if I'm given 5 plus y divided by x, right? So it's 5 plus y is minus 2 all over x is minus 4, right? So the negatives will cancel out. So we have 5 plus 2 over 4. And 5 plus 2 over 4 is the same thing as 1 over 2. So this gives us 5 whole number 1 over 2 or 11 over 2. Now let's look at like terms and unlike terms. So terms with exactly the same variables raised to exactly the same powers are called like terms or similar terms. Terms which are not like terms are called unlike terms. The coefficients have no effect on whether two terms are like terms or not. When adding or subtracting like terms, the coefficients and the result stays the same of the term. And when adding or subtracting unlike terms, there is no way of combining the terms and cannot be simplified. Okay, so now let's work examples. When given something like 5x minus 14x, so they have the same variable and they are of the same term. So this is what we call the coefficient, the number which multiplies the variable. Because they are the same variable, we can subtract their coefficients. So 5 minus 14 gives us minus 9. Then we still have to add the variable because they are of the same term. Another example, if you are given x squared plus 2x, plus 7 minus 14 minus 10x minus 5x squared. So in order to solve this, we need to group like terms. So we need to group all the ones with x squared. So we have x squared, then we use count through to find whether you have any x. So we have what minus 5x squared, then we have what plus 2x, there's another what minus 10x, then we have plus 7 minus 14. Okay, so we subtract the coefficient. So we have what here is what 1. So we have 1 minus 5, which is what minus 4x squared, plus we have 2 minus 10, which gives us what minus 8x, then plus 7 minus 14, which gives us minus 7. So we have minus 4x to the power 2 minus 8x minus 7. Okay, so with this, they do not have any like terms. So it means we cannot simplify. So it remains as how it is. Another example, we have 5m minus 11n plus 2n plus 18m. So first we group like terms. So we have 5m plus 18m minus 11n plus 2n. So we can add the 5m and 18m, which gives us 23m. Then we have minus 11n plus 2n, which gives us minus 9n. So we have what minus 9n. So this gives us what our final answer. And with the last example, if you are to simplify 5 2x plus y plus 1, then minus 3x minus 2y. Okay, so with this we need to multiply through by the numbers outside the bracket. So we have 5 times 2x, which is 10x, then 5 times y, which gives us 5y, plus 5 times 1, which gives us 5, minus 3 times x, which gives 3x, then minus 3 times minus 2y. So minus gives us positive. So 3 times 2 will give us 6, so 6y. So now we group like terms. We have 10x minus 3x plus 5y plus 6y plus 5. Okay, so we have 10x minus 3x gives us 7x. Then 5y plus 6y gives us 11y. Then plus 5. So you'll be able to evaluate and simplify this algebraic expression. So this brings us to the end of our lesson on algebraic expressions. In our next lesson, we'll be looking at linear equations.